Hello viewers, in today's lecture we are going to take up some problems based on integration by parts. In our earlier videos we have already discussed the concept of integration by parts. So here we are going to solve some important problems related to this method. So the formula for doing these problems is written here. Here u and v are two functions of x, and the formula for integration by parts is written here, and it is used for integrating the product of two functions, right? So let us take the first problem. So here we have to integrate the product of x and cos inverse x. So let us call this integral as I. Now here we will make use of the result or the rule that the first function will be taken as the inverse function. This is the inverse function and this is the algebraic function. So this is the first function, that is u, and this is the second function v, right? And here we have used the rule I late, right? So I stands for inverse trigonometric function and a stands for algebraic. So I comes before a. So this cos inverse x is taken as first function and a comes after I. So x is taken as the second function. Okay, so let us substitute the value of u and v in this formula. So we get u is cos inverse x, then we have integral of x, then we have integral here, the derivative of cos inverse x, then we have integral of x, and here we have dx. So this integral is x square by 2, and this is cos inverse x minus here we'll have the derivative as minus 1 over square root of 1 minus x square. This is x square by 2, and here we have dx plus c, right? C is the constant of integration. Now this can be written as x square by 2. This is cos inverse x minus minus plus. So we have half, and we have x square divided by square root of 1 minus x square. And here we have dx plus c. Now our aim is to find the value of this integral, right? So let us call this integral as I1, and let us take I1 as x square over square root of 1 minus x square, right? Now in order to evaluate this integral, we can apply various methods, but here I am going to solve it by using method of substitution. So let us substitute x is equal to sine theta. So dx is equal to cos theta d theta, right? So therefore this integral becomes x square is sine square theta, and here square root of we have 1 minus sine square theta, then we have for dx we have cos theta d theta, right? So this is sine square theta, and this is 1 minus sine square theta is cos square theta, square root of cos square theta is cos theta, and then we have here cos theta d theta, cos theta get cancelled. So we have sine square theta d theta. This can be written as half 2 sine square theta d theta, and this can be written as half, and 2 sine square theta can be written as 1 minus cos 2 theta, right? Okay, now this can be written as half here we have theta minus the integral of 1 is theta, integral of cos 2 theta is half sine 2 theta, right? Now this can be written as half, and for theta we can write sine inverse of x, because here theta is sine inverse of x, and here we have minus half. Sine 2 theta is 2 sine theta cos theta, and this is half, this is sine inverse x, minus 2 and 2 get cancelled. We have, for sine theta we have x, and for cos theta we can write 1 minus square root of 1 minus sine square theta. Sine square theta is x square, right? Okay, because here sine square theta is 1 minus cos square theta, right? So cos theta is square root of 1 minus sine square theta, that is equal to square root of 1 minus x square, right? So the value of this integral is half sine inverse x minus x times square root of 1 minus x square. Now substituting this value here for this integral, so therefore the value of this integral I is equal to we have x square by 2 cos inverse x plus we have half times this integral, and this integral is half sine inverse x minus x times square root of 1 minus x square plus c, right? Therefore the value of I is x square by 2 cos inverse x plus 1 by 4 sine inverse x. This is half times half is 4, 1 by 4 sine inverse x minus 1 by 4 x times square root of 1 minus x square plus c. So this is the required integral of the given integral x cos inverse x, right? Now let us take this problem. So here we have to integrate x times log x square, right? So let us call this integral I. Now here again we have the product of two functions here. So again we will make use of the rule I late, and here this is the logarithmic function, so this can be taken as the first function, that is u, and this is an algebraic function, so this is taken as second function. So this is the first function, this is the log function, and this is the algebraic function, right? So let us substitute the value of u and v in this equation. So we get we can write log x whole square here, then we have x dx, then minus integral of the derivative of log x square, and then we have integral of x dx, and this is dx, right? So this is log x whole square, here we have x square by 2 minus, and here we have 2 times of log x, and then we have 1 upon x, because making use of chain rule, and here For this integral we have x square by 2, and then we have dx plus c. C is the constant of integration. So this can be written as x square by 2, this is log x square, and minus here 2 and 2 get cancelled, here x and x get cancelled. So viewers, we are left with x log x dx plus c, right? Now it is very interesting to see that this integral again becomes a product of two functions. See, this is the algebraic function, this is the logarithmic function, and L comes before A. So this can be taken as the first function, this can be taken as the second function. So in this integral we will apply the parts formula, and here we will make use of again this formula, right? So this is minus, and this is the first function, that is log x, integral of x, then we have minus, here integral sign, then we have the derivative of log x, and then we have the integral of x, and here we have dx, right? And then we have plus c, right? Okay, so we have x square by 2, here we have log x square minus, and here we have x square by 2, so we can write it as x square by 2 log x, then we have minus integral, then the derivative of log x is 1 upon x, then we have x square by 2 here, and dx, and then we have plus c. Now this can be written as x square by 2 log x whole square minus, we have x square by 2 log x, and minus, here we have half, and c, we have here we have 1x, x raised to power 1, and the integral of x is again x square by 2, right? And here we have plus c. So therefore our final answer is x square by 2 log x whole square, then taking this negative sign to this term and this term, we have minus x square by 2 log x, and plus x square by 4 plus c, right? Now viewers, let us take this third problem, and here we have to integrate x sec square x. So let us call this integral as I, and here we have the product of two functions. This is the algebraic function, this is the trigonometric function. So we use the rule I late, and here we see that the algebraic function, it comes before the trigonometric function. So this is treated as the first function, this is treated as the second function, right? So let us apply this formula, and for u we have x, for v we have sec square x. So applying this formula, we have here x, integral of sec square x dx, and then we have integral sign, here we have the derivative of u, that is x, and then we have the integral of v is sec square x dx, right? And here we have dx. Now we know that the standard formula for uh, the integral of sec square x is tan x. So here uh, we have x, then we have tan x, and minus, here we have integral, then the derivative of x is 1, here we have tan x, and then we have dx, and plus c. C is the constant of integration. So this is x tan x minus integral of tan x, right? We have integral of tan x. Now this is x tan x, and we know that the integral of tan x is minus log of cos x. So here if we substitute this value, then this sign becomes plus, and we have log of cos x plus c. So this is the integral of x sec square x. Now viewers, let us take this problem. Here we have to integrate tan inverse x. So let us call this integral as I, and here we see that there is only one function, right? So what we will do here, we will take 1 as the second function, right? So this integral can be taken as a product of two functions, right? So again we will make use of isolate, and here this is the inverse function, and this one is the algebraic function, and this is a constant function, and we see that the inverse function I comes before a, so therefore this is taken as the first function u, and algebraic function 1 is taken as the second function, right? So now if we substitute the value of u as tan inverse x and v as 1, u is tan inverse x and v is 1, in this formula we get tan inverse x integral 1 dx minus integral the derivative of tan inverse x integral of 1 here dx, and then we have dx, right? Now this is tan inverse x, the integral of 1 is x minus the derivative of tan inverse x is 1 over 1 plus x square, and the integral of 1 is x, and here we have dx and plus c. C is the constant of integration. So this is x tan inverse x minus, now this expression can be written as half and 2x and 1 plus x square dx plus c, right? Now here we see that we have multiplied the numerator and denominator by 2, so that the derivative of c, the derivative of 1 plus x square is 2x, so the derivative of denominator is in the numerator, and here we will make use of the fact that if we have an integral of this form, fx is the function, f prime x is the derivative of f, so this can be written as log of f of x, right? So here we have x tan inverse x minus half, and this is log of 1 plus x square plus c, right? So this is the integral of this given integral, that is I. Now viewers, let us take this problem. So here we have to integrate sine inverse 2x by 1 plus x square. Now here we see that our integrand is an inverse trigonometric function, and there is no other function uh, except the sine inverse function. So let us first call this integral as I, and here we will make use of the substitution method, and then we will apply the method of integration by parts, right? So let us first substitute here x is equal to tan theta, right? Because here we have to make a proper substitution. So x equal to tan theta, then dx is equal to sec square theta d theta. So this integral becomes sine inverse. This is 2 tan theta divided by 1 plus tan square theta, and here we have for dx we have sec square theta d theta, right? Now this is sine inverse 2 tan theta divided by 1 plus tan square theta is equal to sine 2 theta, right? This is sine 2 theta, and here we have sec square theta d theta. So this integral becomes sine inverse and sine get cancelled, and we are left with 2 theta sec square theta d theta, and this is 2 taking 2 outside, and we have theta sec square theta d theta, right? Now we have to evaluate this integral, and this integral is a product of two functions here. And viewers, in this video we have just solved this problem, that is integral of x sec square x dx we have just solved, and here the variable is theta, but here the variable is x. So here we will make use of this formula, and this is the algebraic function, this is the trigonometric function, and we will make use of I late, and the algebraic function comes before the trigonometric function. So this is u and this is v, and we have just solved this type of integral, and I am directly writing this result here. So we have 2 times of x sec square x dx. So here we have theta, and then we have tan theta, because here the variable is x, here the variable is theta, plus log of we have log of cos x, which can be written as log of cos theta, right? And plus c. Now this can be written as 2 theta tan theta plus 2 log cos theta, and 2 times of c is again a new constant, c prime. Now here theta from here x is equal to tan theta, so theta is tan inverse of x. So we have 2 times of tan theta is x, so we have 2x tan inverse x, right, plus 2, and this is log of 1 over sec theta, right, plus c prime. Now this is 2x tan inverse x plus 2 times of log 1 over square root of, because we know that 1 plus tan square theta is sec square theta, so sec theta can be written as square root of 1 plus tan square theta plus c prime. Now this can be written as 2x, this is tan inverse x, and this can be written as plus 2 times log of 1 plus tan square theta is x square, and this is 1 plus x square raised to minus half plus c prime, right? Because this can be written as 1 plus tan square theta raised to minus half. Now by making use of the properties of log, we have 2x, here we have tan inverse x, and taking this minus half in front of log, and we have log of 1 plus x square plus c prime. So here 2 and 2 get cancelled, so we have 2x tan inverse x minus log of 1 plus x square plus c prime. So the integral of this function is given by this expression. Now viewers, let us take this problem. Here we have to integrate tan inverse of square root of x, and here we have dx, right? So let us call this integral as I, and here again we will make use of the method of parts, but before applying this method of parts, we will apply the method of substitution. So let us put t is equal to square root of x. It means t square is equal to x. So 2t dt is equal to, differentiating both sides, we have dx. So this integral becomes tan inverse, and square root of x is t, and dx is 2t dt, right? So we have 2 times t tan inverse t dt, right? Now this integral becomes a product of this. See, this function is a product of two functions. So this is the inverse trigonometric function, and this is the algebraic, and here we will make use of I late, and see I comes before a, so this is the first function and this is the second function, right? Now applying or substituting the values of u as tan inverse t and v as t in this formula, we have we can write as 2 times t tan inverse t dt is u. For u we have tan inverse t, then we have t dt minus integral derivative of tan inverse t, then we have integral of t, right, dt, and here we have dt plus c. C is the constant of integration, right? So this is 2, and we have tan inverse t times t square by 2 minus integral, this is 1 over 1 plus t square times t square by 2, and here we have dt plus c. So this can be written as if we multiply it by 2, we have 2 tan inverse t times, here we have t square by 2 minus 2, and this is half, so we have t square divided by 1 plus t square dt plus c, right? So this 2 and this 2 get cancelled, this 2 and this 2 get cancelled, so we have t square tan inverse t minus this t square. See, this t square now can be written as 1 plus t square minus 1, right? And in the denominator we have 1 plus t square dt plus c, right? Okay, so what we have done here, we have expressed t square as 1 plus t square minus 1, and from here we will split this function. So we have t square tan inverse t minus we have 1 over 1 plus t square dt plus, this is minus because minus and minus become plus, so we have 1 over 1 plus t square dt, and then we have minus integral of 1, right? Because 1 plus t square minus 1 divided by 1 plus t square can be written as 1 plus t square by 1 plus t square minus 1 over 1 plus t square. So 1 plus t square, 1 plus t square get cancelled, so we have 1 minus 1 divided by 1 plus t square. So here we have minus of minus, that is plus, so here we will have plus sign, and then we have minus 1 dt plus c. So this is t square tan inverse of t plus the integral of 1 over 1 plus t square is tan inverse of t, and here we have minus t and plus c. So now we can write it as t square plus 1 times tan inverse of t minus t plus c. Okay, so we have calculated the integral. Now we have to convert this expression in terms of x. So what we will do, for t square we have x, so we have x plus 1, and for tan inverse t we have tan inverse of root x, and then we have minus t. For t we have square root of x plus c, right? So this is the required integral of the given function, right?